Hi everyone. In this video, we are going to solve a problem. The problem name is number of nodes in the subtree with same level. And the question number is 1519. So let's quickly see what this problem say. You're given a tree that is connected, undirected graph that has no cycle. So we are given with a tree. Let's say this is a tree. And here, if we're making any loop or we can say cycle, that is not going to be given us. We are given with a tree which has no loop or cycle. Fine. Consisting of n nodes numbered from 0 to n minus 1 and exactly n minus 1 edges. So we are given with a tree which will contain some nodes and that node will be range 0 to n minus 1. If I say 5, n is 5. So we are going to have 5 nodes 0, 1, 2, 3, 4, 5, right? And all 5 will be edges connected to each other. So that is clear. Now guys, the root of tree is the node 0 and each node of tree has a label which is a lowercase character given in the string labels. The node with the number I has a labels of 5. So it says that let me make a tree. So let's take this example. Here we can see that we have a node. We have 7 nodes. Alright, so we must have 7 edges. So you can see we have 7 edges. After that we are given a label string. In example you can see we are given a string that is A, B, A, E, D, C, D. Right. So this string is nothing but a label of every node. Here on 0 index we have A. So you can see that on 0 node we are having nothing but A label, right? On first index we have B. So first node will have a B label. I hope this much is clear to you. Now guys, what it say? The edges array is given in the form of edges of A, I, V, I. So here you can see that edges array is nothing but telling us that if 0, 1, that means 0 can go to 1 and 1 can go to 0. So here you can see that in 0 we can go to 1 and 1, 2 we can go to 0, right? After that 0, 2, that means 0, 2 we can go to 2 and from 2 also we can go to 0. So this is nothing but this telling us that the edges between node, right? So this edges array will be given. After that we can say that which means there is an edges between node AI and BI in the tree that we have already discussed. Return an array of size n where answer is the number of nodes in the subtree of ith node which have same level as I node. Now guys, here's the main part. Let me remove all this. Alright. So guys, it says that we are given with a tree, we are given with edges, labels, right? So now we have to return an array. So let me make an array of 7 size because we have n7, 7 nodes, 7 edges. So let me make it 1, 2, 3, 4, 5, 6, 7. Fine. Now guys, we have to return here the number of levels that has come in the subtree. In example, you can see we have a 0 node, right? So we are going to start from root node and in 0 node, we are going to say we have level A. So find out how many nodes are there in this subtree from that particular node that has a level same A. So here you can see that we have one a subtree of 0, 2 also subtree of 0, but 1 doesn't have A but 2 has. So we can say so far we have got 1, right? We got 1. And here 4 also is subtree, but it doesn't have A. 5 also subtree, does not have A. 3 also subtree, doesn't have A. 6 also subtree, but does not have A. But here 2 has an A. So we can say we are going to write on 0 index 2. Why? 1, it itself has A, and second, it got one child that also has A. So we can return 2 because we have 2A for this particular subtree. Now let's move to the 1 index. Let me move all these. In 1 index, how many B? We have a B, right? So we have to find how many B we have in the subtree of 1. So we can say that this is nothing but subtree for 1. And inside of this, you can see we don't have any child which contain B. But this one only contain B, so we are going to return 1. So similarly, we have to do all these things, right? So on 2 also, you can see that we have to find A. How many subtrees that has a level A? No one has A. Only this root node, or we can say 2 node has A. So we can return 1. So similarly, we have to do for all. So we can return 1, right? Because we can see that all the connectors are distinct now. So this is how we can return. But now guys, the question comes how we can do this particular problem. What is the logic to solve this particular problem? So here guys, we can use a DFS, depth first search. So let's move to the logic part and see how we can use a DFS and solve this particular problem. So guys, what I'm going to do, I'm going to write logic, fine. So here guys, let me make a tree again. So I'm going to say I have 0 node, then I have 1 node, then I have 2 node, fine. Then I have 4 and 5, 3 and 6, right? Okay, and they have a label as well. So this has a label A. This has, let me define a label with another color. So this has a label A, this has a label B, this has a label A, and this is D, this is C, this is E, this is D. Fine. So guys, we can say we are going to start from this 0 root node, right? We will say, okay, for now we are going to make an array, or we can say dictionary. But if you are doing a Python, then you can easily make a dictionary. So what I can say, on A I have nothing but 1. So you can see on 0 node we have A1. Now we can see move to all the childs. We are going to use DFS. So we are going to move all the childs. So we are going to come at 1, and here we can say we have nothing but B, right? Fine. From B we are going to come all the childs. So we can say 4. In 4 nothing but D, isn't it? And if 5 we can say nothing but C. Now let's move to the right side. We are coming to 2 from 0. So we can say we have nothing but A is 1. So far we are going to do this, right? So for 3 also same. E is nothing but 1 and D is nothing but 1. Now guys, the main part come, we are going to use a backtracking. So you guys can see that once we see that 4 is the last node, right? We don't have any left node or right node for this 4. Now guys, what we can do, we can start filling our resultant array. So we can say, let me make a resultant array of 7 size. This is 1, 2, 3, 4, 5, 6, and 7, 5. So now at 4, right? This is 0 index, 1 index, 2 index, 3 index, 4 index, 5 index, 6 index. So on 4 we are going to fill now. So for what I am going to fill, we can see that we have a label D, right? So we can say find out how many times D has occurred in our dictionary. So you can see right now it has occurred 1, right? So we can say 4 is containing only 1, right? That is itself, right? Now guys, it will share this data to its parent. So 4 is going to share this dictionary to this parent. So this parent will have now B is 1 and D is 1, right? And guys, this one node is also going to call 5. So let's quickly call this also. We can say in 5 we have C level and C has come only one time. So let's make it 5 index 1. And this C1 is also going to share to this parent. So we can say now this dictionary has C1 as well. So you can see V is coming one time, D is coming one time, and C is coming one time, right? We can say now on parent 1 we have this dictionary, right? So we can say the parent has a level B, right? So we have to find how many times B has occur in this dictionary. We can say it is only occur one time. So we can return on first index, that is 1. All right, now we come to 0, but before that we have to call right subtree as well. So we will come to 2, and on 2 also we have to call first of all this left and right subtree. So come to 3, and here you can see that we have label E, and E occur one time. So let write here third index 1. Now come to right side 6, we have it label D, and D occur only one time. So make it 6 1. Okay, now guys, these both are going to share this dictionary to its parent. So we can say now 2 has nothing but E1 and D1. I hope this much is getting clear to you. Now guys, this 2 has A, and A occur how many times? One time only. So let make it 2 index also 1. Okay. Now guys, this 1 and 2 also share their dictionary with their parents. So we can write here A come how many times? You can see A come 1, and here also was the 1. So A will come 2, and E is 1. Okay. And D also 1. Fine. And this one also V is equal to 1. Fine. D also 1, and C also 1. Fine. So 0 will has a final dictionary, this one, right? And 0 has a label A. So we can say return how many times A has come in this dictionary. So you can say in this dictionary A come 2 times. So we are going to return at 0 index 2. I hope this much is getting clear to you. So we are just maintaining a dictionary. If you are using another programming language, you can maintain an array of this all size. We can say 7 size, array of 7, right? You can do the same thing by using an array. So this is the logic which we are going to use. We are just using a dictionary. We are calling the subtree and telling them just find out how many characters you have in your subtree. So that's all. Let's move to the implementation part, and let's see how we can implement this DFS in the code. Now guys, first of all, what I have to do, I have to make adjacent list, because we don't know how many edges we have in between of nodes. So that will be told by the adjacent list. So let me make it. So I'm going to say adjacent list is nothing but initially I'm going to make empty. After that I will fill it. So I'm going to say empty adjacent list of size n. Here guys, what I have done nothing. I have just created an empty adjacent list of size n. You can see for I in range of n, just create an empty array for every particular index. All right. Now I'm going to fill it. So I'm going to say for a comma b in edges. What I can do, I can say adjacent list of a dot append b. That means from a we can go to b, and from b also we can go to b because it is undirected graph. So I can say adjacent list of b dot append a. All right. Now guys, what we are going to do, we are going to use a DFS. So for using a DFS, let's make it a function name, that is, let's say same level. All right. And in this function name, what I'm going to do, I'm going to pass here node, which tell us that on what particular node we are currently standing. All right. After that, what we are going to do, we are going to use a set here. So let me tell you why we are using a set. Here you guys can see that we have this example, or let's take first example. Here guys, you can see that in this example we have a 0, right? If we are exploring 0, that we don't want it to explore again, right? So we can say that once again, if you're coming at 0, then don't explore it again. So what I'm going to do, I'm going to create a set first of all. Let's say set name is visited. All right. And here it is going to be empty right now. But here what we are going to do, once we are exploring it, we are making it visited, right? So we can say is visited is going to be add that particular node. So once it added in a node, we can say that if it is in our set, then don't explore it again, otherwise explore it. So we are going to call every particular edges which can be possible from that particular node. So we are going to say for new node in adjacent list of our node, right? We can do like this. We can say find out all the node where we can reach by this particular node. After that we can call the same function, but before that we have to check whether it has already been explored or not. So we can say if that new node in our is visited, that means already been explored. So we can say if it is not, then only explore, right? So if new node is not in our is visited, so let me write is visited, then you can explore it. So call it the same function. So we are going to say same function, same level, and here we are going to pass new node. Fine. Now guys, once we have done this, we are going to check one more thing. Remember I have told you that I am going to use a dictionary for every particular node. So I'm going to create an empty dictionary for every particular node. So whenever I'm going to call this function, I'm going to create an empty dictionary, and the dictionary, let's say dic, okay. And after that, it is going to be an empty dictionary. So instead of dictionary, we can use a counter. It will help us to add everything. So you can use a dictionary as well, but here I'm going to use a counter. So this is nothing but same as dictionary, but it keep a count of every character, right, by default. Once you call this function, it is going to return something. So it is going to return our dictionary, fine, because I told you that this dictionary is going to be returned to its parents. So this is going to return that particular dictionary in our parents, and fine. But between that, we have to do something. Remember, we are going to take a particular labels, and we are checking that how many times this label has occurred in that particular dictionary. So I can say that, guys, I have a variable that is going to be result, which is going to be written at the end, and it has a length of 7, right? So I can say result is going to be length of n. Alright, guys, so what I'm going to do now, I'm going to say on that particular node, means result of that particular node, just check how many times that particular character has come. So we are going to take label. So we can say that check in dictionary how many times that particular label has come. So labels of that particular node. I hope this much is clear to you. Here we are just checking that how many times that particular label has come in our dictionary. And label is nothing but labels of node. We are going to take only that particular label which is present at that particular node. And node is nothing but index right now, right? Alright. Now, guys, before checking the frequency of character, we have to add our current character as that, right? So I'm going to say in the dictionary of current character labels of node, that particular character should be added one more time because that particular character is stored in that particular node. Here we can see this particular example, right? In this example, we are taking two nodes, alright. So now we are checking that how many times A has occurred in this subtree, right? So you can see it has come 0 times, but we have to add this one as well, right? A has also come in our two node as well. So take that one also. So we are going to add one more times in that particular dictionary. Now, guys, once we have added, now we have to pass this dictionary to parents node. We can say now parent dictionary will have nothing but dictionary plus equal to the same level of new node. Means it is also going to return one dictionary, and that dictionary will be added in our new dictionary so that we can get the frequency of all the subtrees for that particular node. I hope this much is clear to you. If it is not, so let me summarize you. So we have created a one function that is DFS. So this function is doing nothing but DFS. After that, we are going to make a set so that we can't explore it again. So we are taking that particular node in our set. Okay, once we have taken that particular node, that means if next time we go to that particular node, we will not explore it again. Fine. After that, we have created an empty dictionary right now for that particular node. But, guys, we have to add that particular character also. So we are adding it here. You can also add it above as well. Doesn't matter. So we are adding that particular character which is present in that particular node. Okay. Now we are exploring all the childs, and all the childs that has not already been explored, that only we are exploring. Once we have explored it, now what we are doing, we are taking that particular dictionary from that particular nodes from child into our parent dictionary. So we are adding it all the data. After that, we are finding how many times that particular character has come in that particular dictionary and putting in our result. And after that, we are returning our dictionary. So now if I call this function same level, so let me write a same level. Okay, and here I'm going to pass from 0 node because 0 is our root node. And after that, we can say return our result. So let's quickly run this code. So here, guys, you can see that it got accepted, right? So now, guys, what I can do, I can try to submit this code. So let's submit it. And here we go, guys. It's successfully accepted. If you learned something new in this video, don't forget to hit the like button and subscribe my channel. Meet you in the next video.